Hello, we are going to prove the alternate exterior angles theorem for this video. This theorem states that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent or have the same measurement. To show this theorem, we need to come up with this situation here, where transversal line T cuts parallel lines P and R. And then we need to show that angle A is congruent to angle G, since they are what we call as alternate exterior angles. Before we go to our proof, it's very important for us to declare that lines P and R are parallel, since our theorem strictly states that the lines that are cut by a transversal should be parallel. For the proof of this theorem, we are going to use the two-column proof where we list down all statements and corresponding reasons that will help us yield the intended target. The start of our proof will cover the given statement here. Out from these statements, we are going to look at the relationships of the angles formed that will hopefully yield us to this intended outcome. So again, our first statement here is where the transversal line T cuts, passes, intersects the parallel lines P and R. Since this is given, that's also the reason, sorry, that's also the reason for the given statement. Out from these relationships, we need to look for the relationships between angles since our intended outcome involves angles. For this, we have angles A and angle G. However, it's also good to note that we could also add here a statement where we are going to name or construct an angle that will help us prove this theorem. I'm talking about adding an angle E that is a corresponding angle of angle A. We are going to construct or add this angle so that we could look at the relationships of the intended angles later on. No worries, this will not harm our proof since we are just going to name a specific angle here to be angle E. And by definition, angle A and this angle here, which is angle E, are corresponding angles. Out from that, we could now look into the relationship of angle A and the added angle E. And since they are corresponding angles under the situation where a transversal line cuts parallel lines, we could say that angle A is congruent to angle E. This is actually brought to us by one of the most important postulates for this kind of situation. It's the corresponding angles postulate, which tells us that when two or more parallel lines are cut by a transversal, the corresponding angles formed are congruent. Again, this is what corresponding angles postulate tells us. And hence, it's okay for us to write this way. Aside from this, we could also look at the relationship of the added angle E and the already given angle G. We could say that angle E is also congruent to angle G. These two angles are actually considered to be vertical angles, and we have a theorem which tells us that vertical angles are congruent, and that is actually the fourth reason here, the vertical angles theorem. This supports that this fourth statement, the added angle E and the given angle G, to be congruent. With this, we are one step away in proving this theorem. Once that we have shown that angle A is congruent to angle G, this tells us that the theorem holds. We could apply the last two statements here, and we could say that angle A is congruent to angle G. This actually uses the transitive property. This shows that our statement here has been proven, and that means this theorem is true. This is the proof for the alternate exterior angles theorem, which tells us that if two or more parallel lines are cut by transversal, then each pair of the alternate exterior angles is congruent.